Session 8.2 Hypothesis Testing in 4 steps. For these sessions, we're going to conduct hypothesis testing involving population proportion. First step, you're going to state your hypothesis about the population parameter. The population parameter, this is talking about are you working on population proportion, population mean. You also can test population standard deviation and population variance. For these sessions, we're going to focus on population proportion. And then remember for the previous sessions, we learned how to state the null hypothesis and alternate hypothesis. That would be the first step. Number 2, prepare. Choose an appropriate test statistic. We do have a different formula for the population parameter of the test statistic. If these sessions we are working on the population proportion, we have to find the appropriate test statistic. And then we're going to check the condition. We have to make sure the question is fulfill our conditions. Number 3, state a significance level. Remember for this class, significance level is always given. And then we're gonna calculate the test statistic, and then we're gonna compare the test statistic with the significance level. And then we're gonna use the p-value method to see we're gonna reject or fail to reject the null hypothesis. Last one, we're gonna interpret and conclusion. Make sure you draw the conclusion for your hypothesis testing. Now we're going to talk about the hypothesis test about a population proportion. What conditions do we need to check? First, it has to be random sample. And then we need to have large sample size. How can we calculate it? We're going to use the sample size times the population proportion to see if they do have at least 10 of success or at least 10 of failure. And large population. The population is at least 10 times bigger than the sample size if the sample is collected without replacement. Number 4, independence. Each observation has no influence on any others. Okay, make sure you guys check the condition. You guys can use the TI-84 calculator to double check your test statistic, and also we'll be using the calculator to find the p-value. Okay, let's try the first example together. In 2009, it was estimated that 63% of Americans support the death penalty. In 2014, a poll found that in a random sample of 943 Americans, 538 support the death penalty. Do we have evidence that the support of the death penalty has declined among Americans since 2009? Use a significance level of 0.05. So first, we're going to state the hypothesis. Can you guys write down your null and alternate hypothesis? Make sure you're going to state it's going to be the left tail test or right tail test or two tail test. Let's track the word together. We are working on the population proportion. So H0 equal to P equal to 0.63. And then alternate hypothesis. So they're working on, do we have evidence that support of the death penalty has declined? Okay, decline. So that will be P strictly less than 0.63. Okay, left tail test, right tail test, or two tail test. Strictly less than, so that will be left tail. Okay, first step. Second one, we're going to check the condition. First, the sample is random and independent. This is what we assumed. Okay, sample is random and independent. Second one, do we have a large sample size? I want you guys to try to plug it in this formula. N will be your sample size. How many samples do we have? In a random sample of 943, okay, N equal to 943. The P naught, this is always talking about your hypothesis, which is going to be 0.63. So it's going to be equal to 594. That be strictly greater than 10. Okay, and then we're going to check for the sample size, the failure. Plug it in. You're going to get 349. Okay, one more condition. Large populations. So the population of Americans is greater than 10 times of the sample size, right? For sure, it's more than 9,430, right? And also, we assume this is going to be the independent sample. Okay, so number 2, check the conditions. Okay, now number 3, we're gonna find the test statistic. But before that, we need to know what is the sample proportion. Okay, remember the formula for the sample proportion? Sample proportion equal to the number of success divided by sample size. Okay, number of success is talking about 538. Use your calculator. You should get 0.5705. Try to get more decimal space. Even though for the test statistic, we are working on 2 decimal space, when you calculating the sample proportion, try to get more, okay? Now, plug in this formula, find out the test statistic. Sample proportion minus the population proportion, which is, you guys can find it in here, right? 0.63. Use your calculator. Remember how to plug it in. And 1 to 2 decimal space. You should get negative 3.78. Okay, actually, like negative 3.78, the test statistic is really small. Okay, that's talking about 3.78 standard errors below the mean. Okay, the negative talking about below the mean. And then we're gonna use the technology to find the p-value. Okay, but before that, I want to show it to you guys how to use your calculator to find out the test statistic. So make sure you put the frequency on the top here. Okay, frequency on the top divided by square root 0.63 times frequency 1 minus 0.63 divided by 943 cos frequency. Make sure the square root is including the 943 also. Okay, enter. So you're gonna get negative 3.784. We want a 2 decimal space, that will be negative 3.78. Okay, before we finding the p-value and I show you guys the picture, I want to show you guys how to use the TI-84 calculator to find out the p-value and double check your test statistic. Okay, so here you're gonna click on the stat, go to the test. You're gonna find one proportion Z hypothesis testing. This one is talking about 1 populations. Later on, we're gonna learn 2 populations. Okay, 2 population will be number 6 in here. Okay, right now we're working on 1 population. 1 population proportion Z-score hypothesis testing. We're gonna input the p-naught, which is gonna be your hypothesis, which is 0.63. And then the X, number of success, that will be 538. And then N, sample size, 943. And then this one is talking about your alternate hypothesis. Okay, make sure pay attention for this guy. That will be from your alternate hypothesis. We have a not equal to, strictly less than, strictly greater than. So our test is left tail test, left tail. So we're gonna choose the left tail test, enter. And then we're gonna go to calculate. So you're gonna see the first one, they're showing you guys the alternate hypothesis, less than, good, right? The Z will be the test statistic. This is what we get, negative 3.78. On the midterm, I need to see you guys show all your work. Okay, make sure you show all your works in the midterm. Don't just give me the final answer of the test statistic. And then you're gonna see the P here. The P is talking about the P value. Okay, and then the P hat, that will be the sample proportion. This is what I get from here, 0.5705, 0.5705. Okay, again, I need you guys to use the formula to find the sample proportion. And then for the p-value here, I want you guys to pay attention. You could see the p-value equal to 7.744009. And then, do you guys see the E here? Okay, the E here is talking about the scientific notation. Let me show it to you guys here. P-value equal to, according to your calculator, 7.744. And then when you see the E at the end here, this is means times 10 to the power of -5. Okay, this is gonna be your scientific notation. Okay, when you see the E, means times 10 to the power of -5. So you're gonna see 10 to the power of -5. When you have a negative, means you're gonna move the decimal space to the left, okay? 5 to the left. So you could count from here. 1, 2, 3, 4, 5. So your p-value actually is really small. Okay, one more time, when you guys use your calculator on the exam, pay attention on the last part here. Do they have the E here? E will be the scientific notation, means times 10. -5 will be the exponents for here. Okay, so your p-value should be equal to 0.00007744, which is really small. Okay, after you find the test statistic, you could use your calculator, write down the p-value. Okay, so number 4, interpret and conclusion. We do have the test statistic, and we just use your calculator to find the p-value. Now, we're gonna look at the picture here. We do have a left tail test, okay, left tail test. And also, the Z equal to -3.78, which is really small, somewhere like here. That will be our test statistic. And significance level is given. That will be 0.05, right? Left tail. So remember, what is the significance level? This is talking about the area of the left tail. So meaning that somewhere like here, the area of the left tail will be equal to 0.05. And we want to compare the test statistic with your significance level to see if we will reject or fail to reject. But the Z, the test statistic, will be the Z-score. Alpha will be your area. So we can't compare with these two guys. So what we're gonna do, usually we'll be using the test statistic to find out the p-value. But right now, you guys just use the calculator to find the p-value. So we'll be using the p-value compared with your significance level. Remember the p-value method? If your p-value is less than or equal to the alpha, then we're going to reject. If your p-value is going to be greater than the alpha, that will be fail to reject. So you're going to compare with these two numbers. So obviously, p-value will be less than or equal to the alpha. And we're going to reject the null hypothesis. Okay? Now, draw the conclusion. You guys need to know how to draw the conclusion. We're going to say, there is sufficient evidence to support for the death penalty has declined among Americans since 2009. So this sentence, you could copy from the claim statement. Will be like here. Do we have evidence that support of the death penalty has declined among Americans since 2009? Okay, since we reject the null hypothesis, we reject this guy. We believe alternate hypothesis is going to be true. So we're going to say there is sufficient evidence to support for the death penalty has declined. Okay, I need you guys review these questions one more time. For sure, you will see it on your midterm 3. First, state the null hypothesis, alternate hypothesis. Write it down, left tail, right tail, or two tail. And then, check the condition. There's a 4 requirement. Find out the test statistic. Using the formula, plug it in, find out the test statistic. And then, you can use your calculator to find the p-value. I need you guys draw this picture as well. Okay, show me this picture. And then compare your p-value method with your significance level. Tell me it's going to be reject or fail to reject. At the end, draw the conclusion. Okay, if I say fail to reject, that will be there is not sufficient evidence, blah, 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 blah. Okay, please write the complete sentence. Okay. Okay, example 2. I want you guys try to do it by yourself. Let's try to work together. Suppose a pool of 250 randomly select voters in a city found that 140 of them favor increased funding for public libraries. Based on this poll, could we conclude that a majority of voters in this city, more than 50%, favor increased funding for public libraries? Use a significance level of 0.01. Okay, population proportion. And then we have more than 50%. So we could say P equal to 0.05. So we could say that P equal to 0.5. And then alternate hypothesis. Favor increased funding for public libraries. Increase. So it's going to be P greater than 0.5. So this is going to be white tail test. Okay, check the requirement. First, sample is random and independent. Large sample size. Okay, n times the p naught. P naught will be 0.5. Sample size will be 250. So this is good, at least 10, right? And then check the failure here. It's also same thing. Good. Okay, large populations. We assume the population is going to be more than 2,500, right? Good. And independence. Check the 4 conditions. Now, find the test statistic. First, find the sample proportion. Plug it in. You should get 0.56. And then, plug into the formula. Okay, we have the sample proportion minus population proportion, which is 0.5, divided by this guy. Use your calculator, you should get 1.897. Okay, 1 to 2 decimal space. Usually the C-score will be 1 and 2 decimal space. Okay, so that will be 1.90. Now, use your calculator to find the p-value. You should get 0.0289. And then we have the whitetail test. And also the test statistic 1.90, somewhere like here. Okay, that will be your test statistic. And then we have the significance level 0.01. Okay. 0.01 is talking about somewhere like here, the area of the whitetail. You could just think about it. The p-value will be the area of the test statistic, this part. So the area of this part will be about 0.0289. And then now significance is gonna be the area of the whitetail. So you could think about it's about like half of it. Okay, half of it. And then we're gonna compare the p-value with your significance level. Okay, using the p-value method. Compare. It's gonna be greater than or less than or equal to alpha. That will be strictly greater than, right? So we'll be fail to reject the null hypothesis. Okay, fail to reject means like the null hypothesis is gonna be correct one. So draw the conclusion. There is not sufficient evidence to conclude for the majority of voters support increased public library funding. Example 3. Suppose we are testing people to see whether the rate of use of seatbelts has changed from a previous value of 88%. Suppose that in a random sample of 500 people, we see that 450 have the seatbelt fastened. Could we conclude that the proportion who use seatbelts has changed? Use a significance level of 0.01. Okay, first state the null and alternate hypothesis. So we have p equal to 0.88. Okay, 0.88. And then what is your alternate hypothesis? Will it be strictly less than, strictly greater than, or not equal to? Look at the claim statement here. We conclude that the proportion who use seatbelts has changed. Has changed. It doesn't mean increasing or decreasing, right? So we will be using not equal to. So that will be two-tailed test. Okay, check the condition. Sample is random and independent. And large sample size, we're gonna calculate. Okay, n times the p naught. So at least 10, right? And then the value here, also at least 10, that's good. And then large population. So we assume the population is gonna be more than 5,000. And then independence. Okay, state the condition here. Now, find the test statistic. Before that, find the sample proportion. Plug it in. You should get 0.90. And then plug in the formula of test statistic. We know the sample proportion is 0.90. And that will be from your null hypothesis. Plug it in. Use your calculator. You should get 1.376. Okay, 1 to 2 decimal space, 1.38. Okay, interpret and conclusion. Use your calculator to find the p-value. And make sure you remember this is a two-tailed test. So the p-value is talking about the area of two tails. So the picture is going to be like this. you have the test statistic 1.38. 1.38 is somewhere like here. Okay, since this is a two-tail, so you're gonna draw another one that will make it like negative. Okay, one more time. This is two-tail test. So whatever you get it here, you can gonna make it like one positive and one negative. Significance level is gonna be 0.01, and this is talking about two tails, saying that the area of each tail will be divided by 2 for this guy, which is gonna be 0.005. Okay, one more time, because this is two tails, so the significance level, you need to divide it by 2. Left tail and right tail here, add it up, that will be equal to your significance level. So same idea with your p-value. The p-value 0.1687. This is talking about the area of these two tails. Okay, the big tail here, the big tail here. Okay, add it up, these two areas, that will be equal to 0.1687. Okay, make sure you guys know how to draw this picture on your exam. And then compare with your significance level, p-value compare with your significance level. Greater than, right? Obviously. So that will be fail to reject. Now draw the conclusion. There is not sufficient evidence to conclude that the proportion who use seat belts has changed. Okay, we don't know it's going to be increased or decreased, but we know it's going to be changed. Okay, make sure you guys understand these sessions. For sure, you will have similar questions on your midterm. And then for next chapters, we also working on the hypothesis testing with population mean. That's it.